Hi everyone. So this is going to be part 2 of the features of the land pattern template that I developed, and the topic for today is going to be how to use the Playerland Randomizer, or PLR for short. And we're going to go straight into an example to start here. So this map is called Apennine, and we can see what it looks like here. The objective is to have two bodies of water at the sides of the map. The players in a circle, more or less of a circle here, with a mountain in the middle of the map. And when we're dealing with maps that have asymmetrical borders, what I mean by that is the left and right borders of the player lands are not the same as the top and bottom borders of the player lands. And we can see that here. The right and left border are 8 in this case, and there are no restrictions on the top and bottom borders. And so let's try to notice a couple things about the random placement in this map. So when we're in this particular situation, we can notice that we can run into problems here where a particular player can spawn too far into the middle of the map so that he is completely surrounded by rock terrain here. And that's a pretty rare occurrence. Like if we keep generating, see, it doesn't happen very often, but it can happen. And also notice that it's fairly consistently noticeable that players towards the top side of the map are able to spawn much closer to the edge compared to players at the bottom. So we can see that he can spawn fairly close to the top here, while these players at the bottom are very far away from the edge. And we can see more or less that's fairly consistent when we're dealing with asymmetrical borders, like this map here. And now we can talk about a couple things that we can try and do to try and fix this. So when we're working with Definitive Edition, the typical way of giving more constraint to the player spawn locations is with a circle radius. And we can see what that does here. But in the case of an asymmetrical map like this, we can run into a problem. Since when we're dealing with a small radius, relatively small, 33, we can notice that there's going to be a bit of unused map at the top and bottom of the map, which isn't exactly ideal. And if we increase that radius to, say, 39, we can see that we're starting to encroach on the bodies of water at the edge of the map, which is also not ideal. So if we go back to our template here and we go to the main sheet, instead of constraining the player lands to be along the lines of a circle, it would be preferable to, say, for example, constrain it along the lines of an ellipse, like this. And we can do that relatively easily. So what we can do is match the parameters of the ellipse to the parameters of the player lands. And then we can use these lands with using direct placement. So this only defines the location of those land generation spawn points. But let's take a look at the other situation, the create player lands, and we'll look at some of the other attributes we would need to use also. So let's use a terrain type grass. And instead of land percent, we're going to use number of tiles. It's going to be 750, and then we can pretty much copy these other attributes as well. So the right border and the left border, we can get the border fuzziness, we can get the base size, we can still set zone by team, and finally we can still keep our other zone avoidance distance. So now that that's been put into the template, we can try and see what this does here. So we will take a copy of the map we just looked at. So this is the copy, and what we can see here is the player lands have been commented out, and notably we have switched from a random placement setup to a direct placement setup. And so if we replace the player lands with the lands that we have generated here. Let's take a look and see what this does. A player, instead of normal map, we'll use the copy map. So we can see in this situation that the player spawn positions are much more consistent. We don't ever get into a situation where one player is able to spawn too close to the center of the map to be fully enclosed with rocks. And we can see we can have a fairly better use of the map space in this particular setup where players aren't able to spawn close to the top side and far away from the bottom side. We have a much more evenly balanced distribution of player spawn positions in this scenario. So, even though we've achieved some consistency using a direct placement setup, depending on how you look at it, there can be a drawback also. So let's go back to the template, and what I'll do here is I will change the color of a couple of these points here. So these green points are going to be representing Team 1's lands, and then the remaining orange dots are going to be representing Team 2 spawn locations. So based on this setup, we can notice that Team 1 is going to occupy the same 4 positions every single time we generate this map, as opposed to random placement where, for example, we could spawn it like this, or we could rotate it and, we could have a different orientation. So the particular team could occupy one side of the map versus the other. It could occupy the side of the map, it could occupy the bottom of the map, etc. And that's something that we're practically missing out when we limit the spawn locations to be specific points. And this is where the Playerland Randomizer comes in. So if you can see what I'm doing here, all I'm doing is I'm varying the angle of the starting land, and since all of the subsequent lands are referenced from it, those would change also. So what the Playerland Randomizer does is it does that automatically and stores those positions and chooses a random one to add a bit of variance while still maintaining the consistency that we are having with a direct placement setup. So before I begin, I need to mention that this portion of the template uses Excel macros to write code. So if you want to get this section to work, you're going to have to make sure macros are enabled. There's usually a ribbon at the top that'll ask you if you want to enable macros. You just say yes. But when we're looking at this section, the PLR, what we can do is we can generate a certain configuration of lands based on some parameters. So we have the different player setups here between 2-player and 8-player. We have the number of configurations for each player setup. So right now it's set to default to be a full circle, which means that however much you specify the angle will drive however many configurations there are, but it can be different. And then the angle is basically saying what is going to be the starting angle change with each configuration. So for this particular situation, so notice we can only generate a single player setup at a time. And that's generally because the PLR section will reference the main sheet in order to generate the different configurations, and you're likely going to want to change the player setup in the main sheet between each configuration. So we're going to take a look at a 7-player configuration just because, and when we have to go back into the main sheet, instead of having the angle increment at 45 degrees, it's going to be 360 divided by 7, which would be about 51 degrees. And the way this works is that we have a 7-player setup, which means the first 7 lands are the ones that the PLR is going to look at. And when we have our angle set to 30 degrees, all that's going to do is it's going to take these 7 lands and then take a snapshot of that at 0 degrees. And it's going to increment that by the angle, which we have defined here. And it's going to take a snapshot of the lands now that they have all been rotated. And then it's going to increment that angle by another 30 degrees and then take a snapshot there until it's taken 12 total snapshots. And then we have team positions here. So we have default team positions are hard-coded into this template. So we have a generic warm colors versus cool colors setup, with the cool colors being the larger team in the case of uneven teams. And if you happen to not like those default team positions, you can change it to custom team positions, in which you can define the team colors yourself. So instead of the default, we're actually looking at 7 players here. So instead of the default for 7 players, which would be 1, 3, 5, 7 versus 2, 4, 6, we can have 4, 5, 6, 7 versus 1, 2, 3. We could do it that way. But for now, we'll just use the default team positions. And then when we're trying to generate the code, we can define our start row here, which is the row to start printing codes. That would be row 5. And then when it chooses its column, it looks for a specific header. So since we have the PLR configured for 7-player, it will look and it'll find the 7-player header here, and that's the column that it's going to start printing our code in row 5. Include random. So this includes a random structure that'll randomly select which configuration based on the parameters we've defined here. If you're going to be using multiple configurations with the same player setup, you don't necessarily have to include the random structure every single time. That's why it's optional. And a comment here, which will just go into the land. So this can give you something to search for if you need to find it in the script. And also the color of this particular cell is going to highlight that particular section of code once it's generated. Variants, we'll get to that in a minute, but for now, I think we can just hit the generate button and see what it does here. So the first thing I want to mention here is that when we have team positions set to something other than off, whatever assignments we have in the main section are overridden. So since we have everything set to the default positions, the assignments are going to be what we see here: colors 1, 3, 5, and 7 versus colors 2, 4, and 6. And then, yeah, we can see what happened here. We can see the random structure generated, which, since we said we want 12 configurations, it'll randomly select among those 12 configurations. And since we have team positions defined, it's going to say there's going to be a 50% chance that team 1 is going to face a certain direction, and a 50% chance that team 2 is going to face a certain direction. And that's what we can see here. So if it's configuration 1, and if team direction is 1, it's going to spawn colors 1, 3, 5, 7 in that order. And if the team 1 is facing the other direction, it'll create the team in reverse, so 7, 3, 5, 1. And with this particular setup, it's going to be relatively easy to show the kind of variance that it produced. So if I go back and I replace our previous land generation code with the updated code that we've just generated, we can switch it from 8 players to 7 players, which is the configuration we generated. And we can see what it's done here. So what have we said here? We said that colors 1, 3, 5, and 7 are all on one team. So let's see, colors 1, 3, 5, and 7 are generated here, and they take up this particular angle, this particular section of the map. And if we generate it again, we can see that 1, 3, 5, and 7 have randomly chosen a different direction to spawn. And if we take a look at this again, now they're occupying a different rotation positions on the map. So now they're taking up the bottom half of the map, 1, 3, 5, and 7. And beyond that, the last parameter that I didn't mention here yet was the variance in terms of percent. So right now, the land configurations are set to an exact coordinate. So for example, this guy is going to spawn at 6786. And if we change the variance, we can change it to, say, 1. We will try to generate this again, and this is actually not 8 players, it's 7 players. But we'll try to generate this again, and we can see starting cell already contains code, but we don't care. We're going to overwrite that. And we can see that instead of a fixed coordinate, it's going to randomize that coordinate. So RMS has the ability to randomize any numerical parameter based on this particular syntax. So RND, and in parentheses, you use a minimum value for that numeric value and a maximum, and it will randomly choose between those minimum and maximum. So it can be, the x coordinate can be as low as 66, as high as 68, and the y coordinate can be as low as 85 and as high as 87. So if we replace this code now, we can see a small degree of extra variance based on the randomness of the coordinates that we specified. And one other thing I wanted to mention, in order for this map to not look perfectly symmetric in a certain situation, I can vary the starting angle. Let's say it starts from 0 degrees, I'll change it to like 17 degrees. See, that looks a little less symmetrical, and I can generate the code again. And you can see just how easy it is to create huge chunks of code based on parameters that we defined to give the map a bit more flavor. Now, let's take a look at what we've done so far. So we have generated about 270 lines of code, and that just encompasses one particular player setup. And this is only a team position setup, so ideally this would only be active when team positions is on. So I would put in this box, if team positions and if it wasn't team positions, it would have to be something else. So we can see that when we're using the PLR to add variance into direct placement setups, we can notice that we have a pretty powerful tool at our disposal at the expense of potentially adding enormous amounts of code into the map. Since this is just one configuration, and say I want to have something that isn't team positions, then when team positions is turned off, then it's going to use the assignments that are in the main section here. So the way to do that is, first I'm going to spawn the first 3 positions for team 1, the first 3 positions for team 2, and then there's going to be 1 position left for the 7th player. And at that point, I can just spawn at team -10 because there's only going to be 1 player left. And now that I'm looking at this, I'm seeing I have zone defined in 2 places. So I have a zone attribute here in case the zones are going to be different. And then I have another set zone by team in this. It didn't really matter in the first generation because whatever argument comes last is the one that's going to be, validated, but that's just unnecessary code there. So now that we have everything configured here and team positions is turned off, what we can do here is we can look at where this particular section of code ended. So we can start spawning this next section at line 281. And so we can type 281 here. And then instead of 8-player teams, it's actually 7. 7-player teams. And then since we already defined the random structure once, we're going to decide not to include it this time. And we can hit, let's change the color here so it stands out a bit more. And then we can hit generate to see what happens there. And so if team position, it'll generate the orange section of the code, which defines the team positions. Otherwise, it's going to define random team positions like this. So it's going to spawn the first, positions for team 1, first positions for team 2, and then the last player at team -10. And it'll work like that. And if, okay, we'll scroll back up to the top here. And actually, this isn't exactly what I want, since this random structure is actually going to be common for all the configurations, not just for the team position configuration. What I'll do is I'll take that out of the if and bring that down here, and we'll just paste this at the top when we need it. So all the code that we've done so far, this team positions layout and the other random team positions layout, is all under the impression that there are 2 teams in the game in a 4 versus 3 configuration. So all of this that we've done so far is going to be in an if statement that says if 4 versus 3. So besides a 4 versus 3, there are other configurations for a 7-player game that we need to account for also. So for example, we have 7 players. It could be a 2 versus 2 versus 2 versus 1. It could be a 3 versus 3 versus 1. It could be a 2 versus 2 versus 3. So there's a lot of configurations that could potentially be supported, but I'm not necessarily going to support all of them. What I'm going to do is, in the else case, I'll just make it a generic free-for-all layout where everyone is randomly spawned regardless of what team they are. And so if I copy this -10 over to all the other positions, that should be good to go. And when we're checking for if 4 versus 3, that's not a predefined constant. That has to be checked based on some other code. So what this particular section of code is doing is it's checking the sizes of the teams. So if it finds a team with size 4 and another team with size 3, then it can define a 4 versus 3. And that 4 versus 3 definition is what we're going to be using here. And then otherwise, which is going to be in this else case, we're going to use that free-for-all layout, which I just mentioned, and we're going to start generating it at line 382, and we can bring this header over slightly so it'll indent properly. So line 382, instead of 7-player teams, it's going to be a 7-player free-for-all. And we'll change the color to be this green. And I think we're good. So generate that. And let's see what we've done here. So if it's not a 4 versus 3, so any other 7-player layout that isn't a 4 versus 3 will take completely random positions regardless of what team. And then we can finally end this if. We can scroll back up to the top here, and then we can put the random structure back over here, so it's going to apply to all of the 7-player layouts, not just the team positions one. And then all this is going to be for 7-player games. So if it's a 7-player game, then it can choose one of these layouts. So now we can take this much bigger chunk of code and paste it back into the game so we can see whether or not this works. So right now we can notice that it's not generating teammates next to each other. For example, the cool colors are supposed to be on one team, so it would be green, blue, gray, and teal. So they are not together, and that makes sense because we have not yet copied over this generic code that's going to check whether it's a 3v4. Since it is a 3v4, after we copy this in, it can be anywhere, we should notice that it would have changed slightly so that the teammates are now next to each other. So the cool colors, blue, green, teal, and gray, are all next to each other on the same team. So let's just take a second to recap what we've done. So in the beginning, we had a random placement set up with only one statement for creating the player lands. In order to change from direct placement, we had to have at least 7 lands, one for each player. And now to introduce that variance back in, let's try and figure out how many lands we have. So we have 7 players, and then 12 configurations. And for the team positions layout, it includes 2 direction possibilities for each team. And then for the other 2, it's just a simple 7 create land statements times 12 configurations for the random team positions, and then for the completely random positions, 84 also. So to introduce that variance back in, we now have a total of 336 create land statements, and that's only for 7 players in the game. You would have to do a similar thing each for a 2-player setup, a 3-player setup, 4-player setup, etc. And if that sounds a little convoluted, that's because it is. The capabilities of the RMS engine can seem rather primitive at times, but this is what we have to work with. But you don't necessarily need to be intimidated by all the code that's in here, because it doesn't necessarily have to be this big. Since, for example, we used a total of 12 configurations for each instance, each scenario that we did. But you may be sufficient with just 4 configurations. You can cut the code into a third of what it shows here. Perhaps you don't necessarily need to support team positions in your particular map. You could cut the code in half that way. So with this tool, you can make these code blocks as big or as small as you choose. You can support as many or as few player setups and map setups that you want. So that's essentially what the Playerland Randomizer is supposed to do. It's kind of supposed to achieve the best of both worlds in terms of preserving both randomness and consistency with player setups. And beyond that, I'm very open to feedback on what other functionality this template could have. As of now, I've designed it to be fairly robust. So, for example, the maximum configs is 100. And if you want to be that guy who says, well, I want to generate 101, it'll say player configs must be 100. So there's checks to see that you're not, that all the parameters you're inputting are legal. Like if you wanted to do custom team colors and you accidentally included the same color on both teams, it'll give you an error that says same color found in 2 teams. And I guess if you want to clear all the lands, you can just hit this clear button and it'll clear all the code for all the lands. And it works like that. So if you're going to be downloading this, make sure you have the latest version. the link I provide to the AOE zone page will always be the most up-to-date version. And I think that's about it for now. So as always, I hope you've learned something, and I'll see you next time.